we're going to take a look at an example of solving an equation that contains rational expressions. So the one that we'll go ahead and look at is n all over n squared minus 9 plus n plus 8 over n plus 3, and that will be equal to n minus 8 over n minus 3. So when dealing with problems like these, the first thing that we want to do is make sure that we have common denominators for each of these expressions. If we don't have a common denominator, then we're at an impasse. We can't go any further. So note right now that the denominators are all slightly unique. So the first thing that I'm going to do is focus all of my attention on the denominator. So I'm just going to rewrite what I have in the numerators for now because I'm not worried about them. Notice that you have n squared minus 9. This is, again, a difference of what? If you said difference of two squares, gold star. So from here, n squared minus 9 can factor into an n plus 3 times an n minus 3. You could probably have used the context clues of the problem and noted that you already had an n plus 3 for this denominator and an n minus 3 for that denominator. That could have been a tip-off that one of your denominators contained at least one of those as a factor. So now we want to note that what the common denominator is. So recall from class we were talking about how if you want to look at, I guess if you're dealing with children, you want to make sure that each child has the exact same thing, because if they don't have the exact same thing, then one of them will be unhappy. So what we're going to do is we want to note the common denominator that we see here. And we'll use that to our advantage to kind of get this all on one playing field and clear the fraction out. So if you notice, I see that I have an n plus 3 occupying 2 out of the 3 rational expressions, and I have an n minus 3 occupying 2 out of the 3 expressions. So what I'm going to go ahead and do is I'm going to multiply each term by an n minus 3. And bear with me while I write this. And what I would actually encourage you guys to do at this point in time, if you haven't already done it, is to pause the video and try to work this problem out on your own. And then what you should do is return back to it and then double check your work against what I'm writing. Oops, I made a mistake there. Sorry. I only have an n plus 3 over here. I got a little carried away. Don't we all while we're trying to solve math problems? Okay, so now what we can do is, because we're going to multiply each term by the common denominator, we are able to successfully clear out the denominators of each rational expression. So notice that I have an n plus 3 up here and an n plus 3 in the denominator. That will cancel, as will these n minus 3s. The n plus 3s on this term will cancel out, and the n minus 3s will cancel out here. So now let's focus and see what we have left. Well, the only thing that we have left in the first term is n. The next one, we have an n minus 3 times an n plus 8. And then on the other side, our third term, we have an n plus 3 and an n minus 8. So, I mean, take a second to think about that. Isn't that kind of interesting that because we are able to locate the common denominator, that allows us to use it as a tool to actually clear out the denominators. It's a very know thine enemy kind of thing. If you can identify the enemy completely, you can take care of it straight away and not have to worry about it later on. So from here, bear with me, and again, hopefully you have been working on this. I'm going to go ahead and break down these parentheses, and hopefully you guys are thinking, if I have a binomial times a binomial, the best way to do that would be to distribute or use our FOIL tool. So here we would have we have n squared plus 5n minus 24, and that is going to be equal to n squared minus 5n minus 24. Okay, so from here, the goal is to start cleaning things up. So I'm going to clean up the right-hand side first, and I'm going to note here that I have two like terms. Okay, they are like terms because each one just has an n. Okay, n squared, for example, is not a like term because it has an n times n, where these just have one n attached to them. So this becomes n squared, and this is plus 6n minus 24. And then there are no like terms to clean up on the right-hand side, so we just have that. Okay, let's clean this up further. Okay, we should still try to combine like terms. So I'm going to add 24 to both sides. And lucky me, those actually will cancel each other out. I'm actually going to also go ahead and subtract an n squared from both sides. And those will cancel each other out, leaving me with a 6n minus, or is equal to a negative 5n. And then what we are kind of noticing here is, well, I still have two like terms, so what I'm going to do is, in this case, I'm going to just add 5n to both sides. And again, this is randomly chosen on my part. I could have subtracted 6n from both sides and I still would have gotten the same sort of solution. So if I do that, I have an 11n, but don't forget, since you're working with an equation, you should see a left-hand side and a clearly labeled right-hand side. Well, I've cleared out the right-hand side, so what do I have left if I have a negative 5n plus 5n? The answer is 0. So if we divide both sides by 11 to get n by itself, we get that n is equal to 0. So some of you are probably going, oh my gosh, you know, like, all that work just to find out that the variable is equal to 0. It can happen. Not every answer is going to be equal to a 2 or a 7 or something along those lines. But as we had said before, we can go ahead and do a check if you don't believe that this is the solution. So everywhere that I see an n, I'm going to substitute a 0 in for it. So I have 0 squared minus 9 plus 0 plus 8 over 0 plus 3 is equal to a 0 minus 8 over a 0 minus 3. So note here that I have 0 over 9 if I clean up the first term, and 8 over 3 if I clean up the second term, and a negative 8 over a negative 3, which, since it's a negative divided by a negative, is a positive. Well, 0 divided by 9 is just 0, so in the end I have 8/3 is equal to 8/3. So let's actually appreciate the fact that you can take something as simple as, I want my answer to be 0, and you can construct something that looks so complex that you're pretty easily able to bury it and really put people through their paces in order to find or dig out that solution. So hopefully I've stated my case. All right, and we're good.